Hi there, welcome to another video from Hegarty Maths. It's Mr. Hegarty here, our second video on the equation of a circle. So let's link back to the first video and what we talked about there. Would you pause the video and I want you to state the formula for the distance between 2 points, two general points, say I gave you x1, y1 and x2, y2. And subsequently I'd like you to use that formula that you should know to find the distance between the points -6, -7 and +3, 5. Pause the video, have a go. Okay, you should know this formula. The distance is given by the square root of the difference in x's all squared add the difference in y's all squared. Okay, and it was an application of Pythagoras' theorem, and I showed you in the last video where it came from. Using that very formula, you could have worked out the distance between -6, -7 and 3, 5. Draw yourself a little picture and then apply the formula and you would have got that the distance is equal to 15 units. Now I need you really good at that. For this particular video we're going to be using the distance between 2 points quite a lot. The next thing I want you to remember is the equation of a circle, and in the last video what we did is we found out that the general equation of a circle with centre AB, radius r, is x subtract a all squared add y subtract b all squared is equal to r squared. And we practiced in the last video, if we were giving the equation in that form, we were practicing stating the centre of the circle and the radius. For example, the following question. I'd like you to pause the video, state the centre and radius of the following circle with that equation and maybe even sketch it. Okay, hopefully you'll remember this was nearly in the form x subtract a squared add y subtract b squared equals r squared. When it is x add 1, you have to write it as x subtract -1 all squared plus y subtract 3 all squared is equal to the number that squares to give 25, which would be 5 squared. And that told you therefore that the centre was -1, +3 and the radius was 5, and you could have drawn it. So what we were good at, just to reflect on that, we were good at having been given the equation of the circle, stating the centre and the radius. What we're going to practice in this particular video is if someone told us the centre and the radius, could we go backwards and state the equation of the circle? And even harder, if someone just told us the centre and some little bit of information to work out the radius, could we go backwards? So let's get straight on and try some of these questions, starting with this one. Pause the video and have a go if you think you can do it. Well, we're told that the centre is the point 1, 2. That's good. We're told the radius is equal to 6. We know that the general form of an equation of a circle is the following. X subtract a squared add y subtract b squared is equal to r squared, where AB is the centre and r is the radius. Okay, so we're in a pretty good shape here. We've got the centre, we've got the radius, we can do this, no problem. It would be x subtract 1 all squared add y subtract 2 all squared is equal to 6 squared, and we're done. And if you wanted to draw it, you would just draw in the centre at 1 across 2 up, something like that. And what you would do is you would then draw a circle of radius about 6, and you would just label in for yourself that you've got yourself the radius here, which you'd say is something like 6, and you'd be done. Alright, let's try another one. Pause the video, have a go. Again, another straightforward one here. The centre is 1, -5. The radius we're told is equal to 2. We know the general form of the equation of a circle must be x subtract a squared add y subtract b all squared is equal to r squared, where AB is the centre. So we just got to substitute in here and say x subtract 1 all squared add, here's where we need to be a little careful, y subtract -5 all squared is equal to 2 squared. And just tidying that up, we would say x subtract 1 all squared add y add 5 all squared is equal to 2 squared. We know that our centre is at 1, -5, somewhere down here. We know we've got a circle of radius 2, so that because it's radius 2, it won't go above here. It will look something like that. And we could just label in the radius of 2 like that. And we're done. Right, next one. This is slightly harder. Pause the video and see if you can work out how to do this one. Now, we are told the centre of the circle, for sure. That's 1, -5. Great. But we're told a point lies on the circle at 5, -2. We're not told the radius of a circle, which is a problem. Now if you think of it, let's just draw a little sketch to get us familiar here. If the center is at 1, -5, which is somewhere down here, and a point on the circle is at 5 across -2, like this, okay, then we must know one thing for sure. And the one thing we know for sure is that the distance between 1, -5 and 5, -2, that must be the radius. So we can work out the radius by working out the distance between these 2 points using our distance formula. Remember what our distance formula is? Our distance formula, which I could write up here, is going to equal the following. So if we want to work out the radius in this case, the radius, which is this distance, is going to be equal to the square root of x2 subtract x1 squared. Let's call these two x2, y2. So that's going to be 5 subtract 1 all squared, add -2 take away -5. So -2 subtract -5 all squared. So the radius is therefore going to be the square root of, this is 4 squared. This here, -2 take away -5 is -2 add 5, which is going to be 3 squared. So 4 squared plus 3 squared. And if you work that out, you're going to get yourself the square root of 16 add 9, which is the square root of 25, which is 5. And look, we've got ourselves our radius. And we can use the general formula now and say that therefore the equation is x subtract a squared, so it's x subtract 1 all squared, add y subtract -5 all squared, so that's straight away going to be y add 5 all squared, when you're getting good at it, is equal to 5 squared. And so the reason this was a little harder, you can see we had to go away and work out the radius first by working out the distance between 2 points. But once we'd done it, it was just generally using the equation of a circle. So one more like that for you, just to double check you're good at these ones. Here we go. Pause the video, have a go at this one. Okay, again we're given the center is -4, 3, and we're given that a point lies on the circle 8, -2. So I'm going to draw this a little sketch to get our heads around this. So at -4, 3, imagine -4, 3 is somewhere here. Okay, and we're told that a point lies at the circle at 8, -2. So let's think of being 8 across and 2 down, somewhere like here. And we know that this is the center, the blue one, and this point here is on the circle. So if we were to draw a circle like this, can you see that the distance between these 2 points must be the value of the radius? So in this question we're going to have to go and work out the radius first using the distance formula, which we should know out of the top of our head. The distance formula is as follows. So to work out the radius here, we're going to say the radius is equal to the square root of, and we're going to, it doesn't matter which one you call x1, x2, let's call this one x1, let's say. So we're going to say -4 subtract 8 all squared, add 3 subtract -2 all squared, 3 subtract -2 all squared. So r is going to be -12 squared, so the square root of -12 all squared, add 5 squared. Now -12 squared is 144, positive 144, so this is the square root of 144 add 25, which is r is the square root therefore of 169, which actually gives us a nice number, which is 13. Now we've got the radius, we have the center, we can just state the equation of our circle. X subtract a squared, x subtract -4 squared, so it'll be x add 4 all squared, add y subtract b squared, which is y subtract 3 squared, is going to equal the radius squared, 13 squared, and we're done. And that's it for this video. Thanks for watching.